All right, everyone. This is homework for tonight. Easy logarithmic equations. Right? I mean, it's just really just logarithmic equations, but these are a little bit on the simpler side. So let's get going on number one. Right? Since these both of these, this equation has both log base 10 on both sides. Remember, if you don't see any number, any base, they're automatically base 10. So since these are both log base 10, that means that their argument, the 3x minus 9 is equivalent to the 2x plus 6, and you're just going to solve from there. So I think I'm going to go ahead and subtract 2x from both sides. That'll leave me with x minus 9 equals 6, and then I think I'm going to go ahead and add 9 to both sides. So I'll get a total of x equals 15, and that's my answer. Okay, number two, the second one, again, you don't see any base on these logs, so they're both going to be base 10. And since they're both base 10 on both sides, then that means that each of the arguments, the negative 4n plus 7, is going to be equivalent to the 3n. Okay, if you don't see it, you're not sure, like how this second part is, log of 3n. If you don't see the parentheses, it automatically means that whatever's behind the log, that automatically is part of the log. Okay, so in order to solve this, you're gonna have to go in. I'd say I'm gonna add 4n to both sides. So by doing that, I'll get 7 equals, so 3n plus 4n will make 7n, and I brought my negative 4 over to this side by doing the addition of 4n. Okay, and then I'm gonna go ahead and divide by 7, and I'll end up with n equals 1. That's my answer for number 1 and 2. So I'll leave it like that. Okay. Next one, they're both log base 10, so we get n equals 12, and that's about it. That's already solved. Number 4, we get 5x minus 7, and that's going to be equal to 3x minus 1. I'm going to go ahead and subtract 3x from both sides, and that's going to give me negative 1 on the right-hand side, and subtract 3x is going to give me 2x minus 7. Then I'm going to go ahead and add 7 to both sides. So if I add 7 from the left-hand side, I'll be left with 2x. If I add 7 to the right-hand side, I'll be left with 6. Okay, and then I'm going to go ahead and finish off by dividing both sides by 2, and I'll get x equals 3. And that's my final answer. Okay. Number 5, back to blue. So this one's a little different from the previous 4 because previous 4 had logs on both sides. Remember what I said about the previous one? If you don't see anything, there's no parentheses. It means that what comes immediately behind the log is a parentheses. So in this case, I'm going to go ahead and subtract 1 first. So this time I'm going to write it down because it is a little bit more complicated. So this is going to be log base 5 of negative 9b is equal to 3. And then now I'm going to use my definition of a logarithmic equation, or convert my log equation to an exponential equation. And that's going to be with 5 as the base, 3 as the exponent, and that's going to equal negative 9b. Okay, I'm going to go ahead and work out what 5 to the third power is. 5 times 5 is 25, and 25 times 5 is 125. So 5 to the third is 125 minus 9, is equal to 9b. Right? And to wrap it up, to solve for b, I'm going to go ahead and divide both sides, 125 and negative 9b by negative 9. So I will get b is equal to 125 over 9, and that's a negative. Right? And that really doesn't simplify much. So that is my final answer. So I get b equals negative, here, I'll put it right here, 125 over 9. If you want to use a calculator, that would be equivalent to negative 13.888. Okay, so a calculator, if you divide 125 by 9, you get negative 13.888. Okay, part B. Again, pretty similar to the last one. Again, there is a parentheses right here, and that's the argument for the log But it does look like I need to get rid of that negative 7 first. So I'm going to divide both sides by negative 7. And that will give me log base 4 of negative 10 r equals negative 14 divided by negative 7 is 2. Excuse me. That was the bell to go home. Okay, now I'm going to rewrite this logarithmic equation into an exponential equation. So I'm going to start with 4 to the power of 2, and that's going to equal negative 10 r. Okay, 4 to the power of 2 is 16 equals negative 10 r. Okay, and then I'm going to go ahead and divide both sides by negative 10, and I will get r equals 16 over 10, and that is a, oops, I wrote it backwards. See what I did? R equals 16 on top and 10 on the bottom, and that's a negative. And then I can reduce that. I can divide each of these by 2. And then my final answer is R equals negative 8 over 5. Right? And if you don't like fractions, then you can divide negative 8 by 5, and you'll get negative 1.66. Sorry, just negative 1.6. Excuse the bell.
Those of you interested in after school snacks,
I'm going to go ahead and divide both sides by 4.
Second chance window.
Then we will end up with log 11 r plus 8 equals 2. And you go ahead and rewrite this as 11 to the second power equals r plus 8. You're gonna work out what 11 square is. That's gonna be 121 equals r plus 8. And then you're just gonna go ahead and get rid of the 8 by subtracting the 8 from both sides. So you get r equals, and 121 minus 8 gives you 113. Right? So final answer, r equals 113. Okay, we got a couple more, and then we're done. Let's see. We are on number 8. Apologies for that announcement, but you guys know, same announcement every day after school. I'm going to go ahead and get rid of the minus 5 by adding 5 to both sides. So by adding 5, I will be left with, sorry, so if I did this, I will be left with log base 3 of x plus 1 equals 0. This is pretty awesome, because now I can rewrite this as an exponential equation of 3 to the 0 power equals x plus 1. 3 to the 0 power is 1, so 1 equals x plus 1. And if I subtract 1 from both sides, I'll just do it here really quick. I will get my answer of x equals, and 1 minus 1 is 0. That's my answer. Okay, number 9. So back to being a little simpler, because there's log base 18 on both sides. So if that's the case, I can rewrite these as 3k squared minus 5k equals negative 6 plus 2k squared. Combine like terms from separate sides, or actually just put everything on one side. I think I'm going to move everything over to that side. Okay. So if I subtract 6, I will end up with, if I subtract, sorry, that was my bad. If I add 6 to both sides, and if I subtract 2k squared, sometimes it helps if you write it, I will end up with k squared minus 5k plus 6 equals 0. And we know from math 2 that we can factor this into k minus 6, k minus 1. Okay. And if I solve each one separately, I will get, and this was back in chapter 2, guys, so I'm not going to bore you with the details, but you will get k equals 6, and you will also get k equals 1. Oh, you know what? I was wrong on that. It is not negative 6 and negative 1. So if you caught that, good job. You can give yourself a pat on the back. Okay. It's actually k minus 2 and k minus 3. That's going to multiply to be 6 and also add to be 5. So your answer, your final solution is k equals 2 and k equals 3. Okay. Number 10. Again, both log base 14 on both sides. So I can rewrite this as 6v minus 1 equals v squared minus 17. And I think I'm going to move everything to the right-hand side. Okay, I'm not even sure why there's a bell. Okay, somebody tell me in the comment, why was there a bell at, what time is it? 2:25. Okay, why is there a bell? Anywho, so I will get v squared minus 6v because I brought this over and it was positive, so now it's negative. And I'm going to bring the positive 1 over because that was a negative. So positive 1 and negative 17 makes a negative 16. That's going to equal 0. So I'm going to go ahead and try to factor this, and I'm pretty confident this is going to factor. So we get v and v, right? And to make negative 16, that's going to be a, let's see, a negative 8 times a positive 2, right? And if you add them, you get negative 6. So you get v equals positive 8 and v equals negative 2. That's your final answer, folks. Okay, last two. Change back to blue. Both log base 19 on both sides. So I'm going to go ahead and rewrite this as, sorry, I'll leave the last word right there. Okay, so I'm going to write this as 7 minus 3r squared equals negative 2r squared minus 6r. And I think I'm going to combine I'm going to move these guys over to this side because I want the positive r squared. Okay, so if I move the negative 3r squared, meaning positive 3r squared, this will make a positive 1r squared. And if I move the 7, the positive 7, it'll be minus 7. So I'll be left with 0. So minus 7 to this side, I'll have a minus 7 here. And that minus 6r is going to be just down for the right. Oops, that's r. Looks like a v. Okay, factoring that, I'm pretty confident this one can factor. R times r. To make negative 7, it'll be negative 7 times positive 1. And that, if I add them together, I'll get negative 6. So this works. Final answer, r equals 7. And r equals negative 1. Okay, last one. And I do have a meeting with Mr. Kirschman in his room. So I'm going to be a little late. But you know what? This is for you guys. Log base 14, both sides. So we will rewrite this as negative 32 minus 3n equals n squared plus 9n, right? I'm thinking, you know what? I'm going to move everything to this side because I want the n to be squared, the n squared to be positive, excuse me. So I will have n squared. If I move this negative 3n, which means positive 3n, I'll have 9, 10, 11, 12n. And if I move this negative 32, it'll be positive 32, which is not going to add to anything. And I'll get 0 left over. And again, I'm pretty confident that this will factor. So n squared makes n and n. 32, but also adds to be 12. Whew. You know what? I think it's 8 and 4. Right? So it's going to be positive 8 and positive 4. So my final answer, n equals negative 8. N equals negative 4. All right. All right, kiddos. That's a wrap.